Energy, Force and Power, question 10. This time we've got a rocket taking off from the surface of the Earth, accelerating to 90 metres per second in a time of 4 seconds. So 90 metres per second in a time of 4 seconds. The resultant force acting on it is 40 kilonewtons upwards. So F unbalanced equals 40 kilonewtons upwards. And we are asked to calculate the mass of the rocket, and we are then asked to calculate the average force of friction is 5,000 newtons, calculate the thrust of the rocket engine. So here we go. For part A, which is to find the mass of the rocket, we need to first find out the acceleration of the rocket. So that will be A equals V minus U over T. A equals, so it gets to 90. If it was launched from the ground, it started from rest, and it did that in 40 seconds. So A must equal 22.5 metres per second. Like so. Having got that, then we can work out the mass. So the mass would be the force over the acceleration, which would be the 40,000 newtons of the unbalanced force. It's important, it's the unbalanced force there, over the 22.5, and that should give us 1,777.77, and this is where this is not the best worded question in the world, because there's a lot of significant figures issues in it. So what I would do is I would round that to 1780 kilograms, and that means I've only got one significant figure in the 40,000. But remember, I'm allowed to have up to 2 extra significant figures in my answer, so 1, 2, 3 significant figures, and that gets me out of any problems there. Other acceptable answers for this part would be 1,800, which would be only 1 extra significant figure, or even 2,000 kilograms, which would be no extra significant figures. And that's obviously not very close to 1,780, and that's why the number of significant figures is a bit of a snag here. In an exam style question, they might sneakily put in a 0.0 to add an extra significant figure and make life a little bit easier. But that's by the by. So part B, the total thrust of the rocket engines. Well, for that, we need to do a bit of thinking. What does the total thrust have to do? It has to do 3 things according to this question. It's got to be providing the unbalanced force. It's got to cancel out the weight of the rocket. And according to the question, at least, there's 5,000 newtons worth of friction. So it's got to account for that as well. So that means it's the 40,000 from the unbalanced force, plus the weight of the rocket, which will be 2,000 kilograms times 9.8. If we use the correct number of significant figures, if we use more significant figures, this will be a little bit less. And if we then add on the 5,000 newtons for the friction, if we add all of that up, we should get 64,600 newtons. So the rocket engine is having to provide 64,600 newtons to cancel out the 5,000 newtons of air friction and the weight of the rocket in order to leave 40,000 newtons as the unbalanced force to cause the acceleration on that mass of the rocket.